The parent function of the absolute value function. We're going to explore the attributes of this parent function. Let's go and start off by creating a graph. So we're making our vertical axis f of x, our horizontal axis x, our independent variable, and our dependent variable. The parent function f of x is equal to the absolute value of x is defined as follows. We are going to look at its parts. Let's look and see what happens to the graph at the positive values of x. As we look at the domain, let's first look at what happens at 0. Let's first look at 0. Well, if x is equal to 0, we have the absolute value of 0. And we know that the absolute value of 0 is equal to 0. So we have the point 0, 0. I'll plot that point right at that spot. 0, 0. Now we're going to graph the value of x when x is equal to 1. Let's look at the right-hand side of that vertical axis. When x is 1. Well, when x is 1, the absolute value of 1 is equal to 1. So when x is 1, the f of x is also 1. When x is 2, the absolute value of 2 is equal to 2. So when x is 2, y is also 2. You see the pattern so far with our points. So the f of 3 is equal to 3. So when x is 3, the f of x is 3. I will plot these points. Notice I'm color coding. The point 1, 1, the point 2, 2, and the point 3, 3. Now let's look at the negative values. I'm going to create another graph with the negative values for the absolute value of x. The f of x is equal to, when x is negative 1, the absolute value of negative 1 is the same thing as f of x of negative 1 is equal to positive 1, because the absolute value of negative 1 is positive 1. So I have the point negative 1, 1. Let's see what happens when x equals negative 2. The absolute value of negative 2 is also positive. Again, we have a new pattern on the left side of that vertical axis. When x is -3, the f of x is +3. So as we were talking at the beginning, the f of x is equal to x is defined as follows. We're going to define it as a piecewise function. When the f of x is a positive number, in other words, if x is greater than 0, well, what happens when x is greater than 0? We have a line whose slope is +1 and y-intercept, the slope is +1 and y-intercept is equal to 0. This gives us an equation of y equals 1x plus 0, or we can just say y equals x. So if x is positive, because x is greater than 0, the f of x is x. And when x is equal to 0, we receive the constant value. The f of x gave us 0. If x is equal to 0, f of x equals to 0. Now let's look at these points on the left-hand side. It went 1 to the left and went up, 2 to the left and 2 up, and on. If x is less than 0, or negative numbers, then the f of x is equal to -x. Why is that the case? Because our slope, our rise over our run, is -1 over 1. So our slope on the left-hand side of that vertical axis is -1, and the y-intercept would be equal to 0 if I extended the line. So my equation is y equals mx plus b, and y equals -1x plus 0, or just y equals -x. Y, or the f of x, equals -x. How can we describe this function? What's a v-shape? And let's look at all the possible x values, or the domain. If you notice, we go from -infinity all the way to +infinity. Or in other words, from -infinity to +infinity, or we could also say all real numbers. The symbol for all real numbers is that R right there. The range. The range are all the possible y values. So the possible y values for the parent functions of absolute values is from 0 to positive infinity, including the number 0. So we include the number 0 and go up to positive infinity. What are the intercepts of this function? The x-intercept is found at x equal to 0. The y-intercept is also at the point equal to 0. Are there any points where the function does not exist? Well, if you notice, because the graph has all positive values as its domain, and any given x value, f of x is always going to be positive. So this graph is undefined at all the negative values. So we're going to say that this graph is not defined at f of x is less than 0. We're going to pause there, give you an opportunity to take a snapshot if necessary.